This video is for Lesson 2.1, Graphing Quadratic Functions. So this diagram is in your notes. Just want to do a quick review of this. This is your parabola, is the name we give to the graph for a quadratic function. The line that divides the parabola right down the middle is the line or axis of symmetry, and it's always identified with an x equals. In this case, passes through x equals 1. So the equation for the line of symmetry or axis of symmetry is x equals 1. Remember, if you just put 1, that's not correct because it's a line, so it has to be x equals 1. The vertex is always a coordinate point. In this case, it is 1, -4. So when you're identifying the vertex, you're always going to be using a coordinate point. The equation you use to find both of these is the x equals -b over 2a. So this gives you your axis of symmetry, x equals, and it gives you the first part of your vertex. So it gives you that x in your vertex. Alright, let's look at an example. This is example 3 in your notes. So first thing you notice is that this is not in standard form. Remember, standard form is ax squared plus bx plus c. So the x squared has to come first, then the x term, then the constant term. So first thing I'm going to do is rewrite this as y equals, instead of f of x equals, and I'm going to put it in standard form. So positive 2x squared comes first. The 8x has a negative in front of it, so minus 8x, and the 9 is positive, so plus 9. Now I'm in standard form. Next step, always is identify your a, b, and c. A is the coefficient of the x squared, b is the coefficient of the x, and c is the constant term hanging off the end. Now, to find vertex and axis of symmetry, my first step is to use that equation, x equals -b over 2a. Remember, you can think of this as x equals the opposite of b over 2a. So if I look at my b here, and it's -8, I want to plug into the equation the opposite of b, so that'd be +8, over 2 times a, which in this case is 2. So that's the same as 8 divided by 4, or 2. So that is the x part of my vertex. So I have my vertex half done, and it's also my axis of symmetry. So my axis of symmetry is x equals 2. Remember, it's got to be an x equals. Now, I would go right down here and start graphing this. So I want to go to x equals 2 and draw my axis of symmetry. So now I know my parabola is this is the middle of my parabola. Alright, let's find the y portion of my vertex. So here's my equation. It says y equals all of this. I know my x is 2, so now I'm just substituting into this equation. Wherever there's an x, I'm replacing it with a 2. Remember to, oh, it doesn't show up very good. Remember to put your x in parentheses here. So y equals 2x squared. Instead of x squared, I'm going to put in my x equals 2 minus 8, x is 2, plus 9. So all I did was go to my equation. Wherever there was an x, I substituted in that 2. Now remember, if you use your parentheses, you can put that whole line in your calculator. So I would have 2 parentheses 2 parentheses squared, don't forget your squared, minus 8 parentheses 2 parentheses plus 9. And I get 1. So that tells me when x is 2, y is 1. That is my vertex. So now I have my vertex and my axis of symmetry. I'm going to graph my vertex. So the vertex is 2, 1 over 2 up 1. So there's my vertex right there. Here's my axis of symmetry. You'll notice that the x in your vertex and your axis of symmetry are always the same. So I'll put vertex on here. Okay, let's keep going. What else do I need to find? Y-intercept. The y-intercept is always the c. So that is 9. So the way you can identify y-intercept is you can say y-intercept is 9, or y-intercept always has an x value of 0. So you could also identify it with its coordinate point 0, 9. Okay, direction of opening. That comes from my A. Well, I said A is 2, which is positive. Whenever A is positive, I open up. So this is what my graph is going to look like. If I'm opening up, I have a minimum. And the value where that minimum occurs is always the y value of my vertex. So the value is at 1. So we'll talk about that again when we get our graph done. Okay, now I need to find some other points to finish my graph. So I want to put my vertex right in the middle. So that's my vertex. And then I want to either pick 2 x values here, 2 less than x equals 2, or 2 above x equals 2. So I could pick 2, 1, 0. And remember, change that to a y. Or I could pick 2, 3, 4. So these x values, I'm simply choosing them. And then to find the y that goes with them, I'm going to replace the x in my equation with the x that I choose up here. So this is just 2 points to the right of my vertex or 2 points to the left. So I like the look of these numbers better, so I'm going to choose to solve for these y's, and then I'm going to reflect them over the axis of symmetry. So when x is 0, so I'm going to say this is y of 0. I'm going to get this, right? Plug a 0 in wherever there's an x. And this is going to be 0, this is going to be 0, so that's just going to be 9. So one of my coordinate points here is 0, 9. You might notice that was my y-intercept. So now I'm going to plot this point over 0 up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now this point is 2 to the left of my axis of symmetry, so I want to reflect it over the axis of symmetry. So I want to go 2 to the right and put another point. I can do that because parabolas are isometrical. Now when you graph these, I always want 5 coordinate points. So I have 1, 2, 3. I need 2 more. So I'm going to find out what y equals when x equals 1. So I'm going to call that y of 1. So into this equation, I'm going to replace the x with 1. 2 times 1 squared minus 8 times 1 plus 9. Remember, you can punch all that in your calculator. But I think I can do this without doing that. So 1 squared is just 1. Remember that exponent only applies to the 1, not the 2. So this is 1 squared, which is 1, times 2, which is 2, minus 8 times 1 plus 9. So 2 minus 8 is negative 6, plus 9 is 3. So when x is 1, y is 3. So there's my other coordinate point, 1, 3. So start here at the origin, go over 1, up 1, 2, 3. Over 1, up 1, 2, 3, yep. This is 1 to the left of the axis of symmetry, reflected over 1 to the right. Now I have 5 points and my axis of symmetry, so I can sketch my parabola. Don't forget the arrows on the end. So let's talk about this minimum. So up here we said it's a minimum because I'm upward facing, and I said the value is at 1. So if you think, where is the bottom of this vertex? It makes sense to say the bottom is at y equals 1. That's why we use the y value when we're identifying where our minimum occurs at. Okay, that's it.